In this lesson, we're going to talk about one of the most important steps in any HYSYS simulation, selecting the appropriate fluid package. Inside the Properties environment, click on Fluid Packages from the left-hand panel. Just like we saw in the Component List section, there's an Add button, and next to it a drop-down arrow. If you click the drop-down, you'll see three options: HYSYS, Aspen Properties, COM Thermo. In this course, we'll be using HYSYS, which is the default library. So if you click Add Directly without using the drop-down, HYSYS will be selected automatically. Now we're inside the Property Package Selection window. Here you'll see a long list of thermodynamic models, each called a fluid package, like Peng-Robinson, NRTL, SRK, and many others. These packages define how HYSYS calculates thermodynamic properties such as enthalpy, phase equilibrium, vapor pressure, and density based on the components you've selected. Choosing the right fluid package is critical for simulation accuracy. Why? Because different systems behave differently. Steam systems follow water-vapor equilibrium. Hydrocarbon gases follow real gas equations. Alcohol-water mixtures require activity coefficient models for accurate vapor-liquid equilibrium. We won't go into the theory behind every model here. If you're ever unsure which fluid package to choose, you can refer to the HYSYS help documentation, which offers guidance on model selection, or look up literature and articles related to your specific application or industry. Let's now look at some commonly used fluid packages and when to use them. Aspen Steam. Use this when working with pure water and steam, such as steam turbines, heat recovery systems, boilers, and condensers. It gives accurate steam properties based on IAPWS formulations. Peng-Robinson, PR. Great for gas processing, natural gas systems, and light hydrocarbons. Widely used in oil and gas and power generation. SRK, Suave Redlich Kwang. Similar to Peng-Robinson, but sometimes better for non-polar gases and systems with moderate pressures. NRTL or Uniquac. These are used for non-ideal liquid mixtures such as water-ethanol mixtures, absorption systems, or solvent-based separations. These models account for activity coefficients and are accurate for vapor-liquid equilibrium of polar systems. Wilson. Also used for non-ideal liquid mixtures, but less flexible than NRTL for multi-component systems. Let's say you want to model the vapor-liquid equilibrium of a water-ethanol mixture. Here, using NRTL would be a better choice than Peng-Robinson, because PR assumes ideal vapor phase behavior, which is not accurate for polar liquids. It's important to understand that not every fluid package is compatible with every component. While multiple fluid packages may be available for a given set of components, you must choose one that is appropriate for the physical behavior of your system. Just because a fluid package appears in the list doesn't mean it's valid or accurate for your selected components. For example, in upcoming lessons, we'll use the ASME steam package to model systems involving pumps, steam turbines, heat exchangers. But here's something important to note. The ASME steam package can only be used with pure water. You cannot use it with mixtures or other substances like air, ethanol, or refrigerants. So if you try to use this package while your component list contains anything other than water, HYSYS will give you a warning or may not allow the simulation to proceed. In contrast, if you are working with water-ethanol mixtures, you should use something like NRTL, which can handle polar, non-ideal mixtures. If you're working with natural gas or hydrocarbons, Peng-Robinson or SRK is more suitable. Choosing the fluid package is not just about personal preference. It depends on the components you selected and the accuracy you need for the application you're simulating. Let's see what happens if I try to select the ASME steam fluid package. If I click on ASME steam in the list, a warning window appears. It shows a list of incompatible components, and here, it clearly tells us that ethanol is not supported by this package. At this point, I have two choices. If I click OK, HYSYS will automatically remove ethanol from the component list. If I don't want ethanol to be removed, I need to choose a different fluid package, such as NRTL or Wilson, which are suitable for water ethanol systems. But since in our upcoming examples we'll be working only with water and using ASME steam, I'll go ahead and click OK. Now, if I go back and click on Component List 1, you'll see that only water remains and ethanol has been removed.